Welcome to another day on the Journey Chez Chem. All right, today we have another lab. I'm so excited. So please do the warm-up questions as quickly as possible, and we'll go over them in a moment. These two questions are designed to help us understand what is going on in the lab. And we want to determine what is the mass of the chlorine in the product. Now we know the mass of the magnesium. We're going to put that on the scale, and then we're going to heat up the materials, and after the water has all evaporated, the product that we have is a magnesium and chlorine combination. And that then, I know the mass of the magnesium, I subtract that out, and that will give me the mass of the chlorine. And from there I can determine, from those masses, I can determine the moles and get the ratio and get the empirical formula. In number 2, the part of the lab that must be done under the hood is when I add the hydrochloric acid. And I know that when I have magnesium plus hydrochloric acid, that is a single displacement. I'm actually displacing the hydrogen, and that will form hydrogen gas and the magnesium chloride. Now, we know that the magnesium theoretically should be with a +2 charge and 2 chlorines. However, we want to determine that experimentally. And it's the hydrogen gas that can create problems because it's very flammable, and we'll be using the Bunsen burner. So we need to do that under the hood. Now what the hood does is it takes vapors and gases out of the room, and it filters them so that when they go, they get caught, the chemicals get caught in the filter before the air goes out of the exhaust. So that's what a hood does, and it protects us, and we like that. So I can't wait to see you, and I'll see you in a moment in the lab. Here we are again in the lab. I'm so excited. I have some magnesium ribbon here, and I'm going to measure out 10 centimeters of the magnesium ribbon right here, 10 centimeters. It's a little bit longer than 10 centimeters, but that's okay. We can do that. And then I'm going to get its mass. And it's very soft, so I'll just put it there in the middle of the pan, and its mass is 0.14 grams. 0.14 grams is the mass of my magnesium. Now I also need the mass of my beaker, and I want to make sure that it goes back to 0, and then I will put my beaker in the middle of the pan, and that is 110.38 grams. 110.38 grams. That is the mass of the beaker. Now, I'm going to take this beaker and I'm going to add the magnesium. I'm going to tear it into smaller pieces so that it has greater surface area, and the hydrochloric acid that we're going to add will react more quickly. And you know I'm the impatient one. Even though I've been doing these labs for many years, I still am anxious. Now, I'm in the hood, and I'm going to measure out 10 milliliters of 1 molar hydrochloric acid. And this is a graduated cylinder, and I will measure out 10 milliliters. Now, this part doesn't have to be extremely accurate, but it's always good to try to be as accurate as possible. And then I will add the acid to my magnesium, and oh, look at those bubbles. It's excitable. We got bubbles going on in there, and that hydrochloric acid is just dissolving that magnesium. Now we know magnesium and chlorine form a compound that is ionic, and therefore we know that it's a salt. Magnesium chloride is a salt, and it is a strong electrolyte. And we know that strong electrolytes dissociate 100% into their ions, and the acid also has water in it. So we have the magnesium dissolving into ions here, and we have the water reacting with it as well, as far as making it a solution. And all of those little pieces need to dissolve completely. And the gas that's coming off needs to go up and out. So it's not in our lab to interact with any Bunsen burner, because that's the next step. We do the Bunsen burner, and you know how excited I get about Bunsen burners, playing with fire. Under controlled circumstances, of course. Now we just have to get this, and I'm swirling it, and swirling it exposes those little particles to the acid and will increase the speed at which we can get it all to dissolve. And it must all dissolve. The pieces are getting thinner and thinner, but they still look long in there. But you just have to be patient. Patience, patience. It's getting close. Just keep swirling. Get that reaction to go. Now remember, what we have in here is magnesium and chlorine. We're going to drive off the water, and that will give us a dry magnesium chloride product. We know the mass of the magnesium. Once we weigh this, we'll be able to get the mass of the chlorine and change those grams to moles. Always have to change grams to moles, because we can't make any comparisons of grams. Grams are totally different, but I know that 1 mole is Avogadro's number of atoms. Now, we are taking a lot of time here because in reality, we have to take time. Sure, we could probably just get it done and come back to it, but we need a real lab experience. And this real lab experience requires patience. That magnesium. Interesting. Now, if I were to set this down and walk away, it wouldn't happen any faster, because then the particles would not be exposed to the acid. And it's necessary for me to observe and to continue to swirl it. Swirly, swirly, swirl, swirl it, swirl it. I see the particles are getting smaller, and I need to be here and doing this. I see that the reaction is continuing inside there. We can see bubbles, and that's a qualitative observation. Something that I can see. When there's gases, there are bubbles. I believe I had a little bit more than 10 centimeters of the magnesium. Therefore, I'm going to add a little extra of the acid, and that should do her. particles are just floating around in there. They're just bubbling away. I see there's getting fewer bubbles. It's the smaller pieces in there. Oh my, we're getting close. Tiny, tiny, but all of it must dissolve. All of that magnesium must dissolve in this solution. Almost. Look at that. There's hardly any in there. Ooh, just one little tiny, tiny piece. And there it goes. See, there's no more. The solution is clear. It's no longer bubbling. And now I will see you at the Bunsen burner. Here we are, my favorite place. I'm putting this magnesium and chlorine solution on my ring stand with a wire gauze, and I am going to light my Bunsen burner. Here we go. The gas is on. Whoa, look at that flame. Now, I'm going to put it under here and watch this beaker. Wow, look at that. Heating up that liquid. It's beginning to evaporate, and it hits the sides of the beaker. And as it hits the sides of the beaker, it cools down quickly and condenses. Now, again, we're going to have patience as we watch and wait for the liquid to totally evaporate off. We want that liquid gone. We are evaporating off this liquid, and remember, we know the mass of the magnesium. We weigh that out on the balance, and we will know by subtracting the mass of this product from the mass of the magnesium, and that difference will give us the mass of the chlorine, and then we will change our grams to moles. Then we divide by the smallest to get the ratio, and it must be within 1/10. I see it bubbling. That means it's boiling. Yes. Now, we don't want it to boil too vigorously, as it could splatter out. Oh, look at that. I'm watching it carefully. Now, that could be a source of error. If it splatters out, I'll turn it down a little bit so we can lessen that flame. Seems to be just right. Evaporating that water out of there, because our acids are aqueous solutions and they have different concentrations, and we'll talk about that in the next semester. But right now we just know that this was the solution that we needed. I heat it up. Questions sometimes are, well, how long will this take? Well, you know what they say about a watched pot? It won't boil. But I'm watching this pot, but it's boiling. But I don't know how long it's going to take for this water to boil off. We just have to be patient. Yes, patience. Well, also, this is an empirical formula lab. This is a very, very important lab because it has some concepts in it that are very, very critical and very basic. We use them even in our upper level classes. Empirical formula is one of the major types of labs that we can do. And It is evaporating. It just takes some time for that liquid to totally go away and leave us with the crystal. And I do see some crystals on the sides of the beakers, the things that have gone up there and attached. I don't want it to boil too vigorously. Turn it down there a little bit. Also, if things boil too vigorously, you can always remove the flame. Just remove the flame from the beaker and that will cool it right down. Sometimes we put a watch glass on the top, and then if we have the mass of the watch glass, we can subtract not only the mass of the beaker, but the mass of the watch glass from the compound, if we were very concerned about the splattering. And I am somewhat concerned. I see some crystals on the side of the beaker. I turned down the Bunsen burner heat, so it's not too much. And I see that the liquid on one side of the beaker is gone because it's bubbling down there on the bottom. And we're not that far away. I see that it's bubbling on the bottom there. Although I do see it is tilted a little bit, and there is more of the liquid on this side than on that side. I just find labs to be so much fun. Oh, that one side there, it's just bubbling. Oh, we're getting to the solid part. Oh, I see the crystal forming on the bottom. We're not that far away. I just am controlling that flame so that it's not too much. Oh my, the crystal's on that side of the beaker. And then we just have to cool it because we cannot weigh things on the scale when they're warm. That damages the scale. And also, remember that hot air rises and it causes it to be buoyant and it causes my masses to be less. And I can see there's hardly any liquid left in there. Just trying to control the bottom there so that we don't do it too quickly. I see some splatters out on the sides there of the beaker, and hopefully we haven't lost any of that material, all that magnesium and chlorine product. Oh my, you can see that crystal's getting whiter because when it's damp it is darker colored, and as it gets more and more dry, then it's going to get whiter and whiter. Oh my, we're almost done. Woo, look at that thing. It's like getting solid in there. And all that liquid is evaporated out into the atmosphere. Water vapor, making a little humidity of our own. Now I want to make sure I get all the liquid out of there, so I want my product to be dry, dry, dry. Yes. Oh my, I see there's little dampness there. I see a little bubbling in there, but just give it a little bit more time to dry out. Very, very nice. Now remember, we're getting an experimental value, so sometimes our ratio doesn't come out to be what the theoretical is of magnesium chloride, with magnesium being +2. Sometimes it could be a little different. But that's just experimental variables, and that's why we do experiments. I think that that's dry. Now we need to let it cool. And I could take it off of here. These are hot hands. I'll take the beaker off of the ring stand and I'll just set it here. And these tables are designed to take hot materials. And therefore it's safe to put materials down there. Now the way that I can find out if it's hot or not without touching it is by just putting my hand over the top, and I can feel the heat rising. You can feel that heat rising. And I am going to let that stand for a moment, and I'll be right back. Well, here we are. Look at that beautiful white crystal. That is some nice crystal that we got there. Now, I'm going to put this on my balance and get a weight. And it's 111.00. Isn't that amazing? I would have never believed it come out exactly 0.00, but we have to show the 0.00 because our scale will measure to that accuracy. And those are significant digits in our lab. And the mass of it is 111.00 grams of my magnesium chloride product. Well, there you go. Those are the data numbers that you need to do the lab, and you can do the rest of it on your own. And remember, the lab report contains the title, the objective, the procedure, the data, all your calculations, any further investigations and conclusions that are included in the lab. You write all of that up, and in a few days you'll need to turn that into your facilitator to be graded. Well, that was some fun, and thanks for being with me, and I can't wait to see you tomorrow. Bye!